For this example, an oscilloscope will be used to measure the frequency and voltage of a signal. When measuring a single source, attach the lead to the channel 1 terminal and select the channel 1 mode. The group of trigger controls on the right of the oscilloscope is used to ensure that the input signal is displayed correctly on the oscilloscope screen. Ensure that the trigger hold-off is set to auto by pressing the button in, and make sure that the source channel is set to the same channel that the input source is connected to, in this case channel 1. The Var dial is used to vary the gain of the input signal. It should be set to calibrated mode by turning the dial clockwise until the click is heard. The set of controls on the left of the oscilloscope vary the position and scaling of the vertical or voltage axis of the signal displayed on the oscilloscope screen. The vertical position dial is used to change the position of the signal's display relative to the grid. It does not alter the actual input signal. The volts per division dial changes the scale of the displayed signal voltage and can be used to ensure that the entire range of the signal is displayed on the screen. To calculate the peak-to-peak voltage of the signal, the number of divisions between the maximum and minimum of the signal must be counted. This value, multiplied by the volts per division setting, gives a peak-to-peak voltage. In this case, there are 5.6 divisions, multiplied by a volts per division of 1 volt, giving a peak-to-peak voltage of 5.6 volts. Adjusting the volts per division dial will change the size of the signal on the screen, but not the signal itself. With this alternate scale, there are 2.4 divisions, multiplied by a volts per division of 2 volts, giving a peak-to-peak voltage of 5.8 volts. The difference in the two readings is due to uncertainty. Always choose the scale appropriately. Make sure that the signal spans as much of the screen as possible while still allowing you to measure both peaks. The set of controls in the middle of the oscilloscope vary the position and scaling of the horizontal or time axis of the signal displayed on the oscilloscope screen. The horizontal position dial is used to change the position of the signal's display relative to the grid. The time per division dial changes the timescale of the displayed signal and is used to ensure that an entire cycle of the signal is displayed on the screen. To calculate the period of the signal, the number of horizontal divisions between successive crests of the signal must be counted. This number, multiplied by the time per division setting, gives the period of the signal. In this case, there are 3.4 divisions, multiplied by a time per division of 10 microseconds, giving a period of 34 microseconds. From this, the frequency can be calculated as the inverse of the period.